High above the Arctic, a swirling mass of cold air circles the North Pole. This mass of air is not just a random occurrence but a significant atmospheric feature that plays a crucial role in our planet's climate system. This is the polar vortex, a natural phenomenon that influences weather patterns across the Northern Hemisphere. It is a vast area of low pressure and cold air surrounding both of the Earth's poles, but it is more pronounced in the Arctic. Like a guardian of winter, it typically keeps the coldest air locked away in the Arctic. This containment helps to regulate temperatures and weather patterns, ensuring that the extreme cold remains in the polar regions. The polar vortex is most stable during the winter months when the temperature contrast between the equator and the pole is greatest. This stark difference in temperature strengthens the vortex, making it more effective at containing the cold air. However, this delicate balance can be disrupted by a phenomenon known as sudden stratospheric warming. This event occurs when there is a rapid increase in temperature in the stratosphere, the layer of the atmosphere above the troposphere. The polar vortex is not a single entity, but rather a large-scale weather pattern. It consists of multiple components including the jet stream, which plays a vital role in its behavior and stability. It is characterized by a strong jet stream, a band of fast-moving air that encircles the pole. This jet stream is crucial in maintaining the structure of the polar vortex and in influencing weather patterns far beyond the Arctic. This jet stream acts as a barrier, preventing warmer air from the south from mixing with the cold air of the Arctic. When the jet stream is strong and stable, it effectively contains the cold air within the polar regions. The stability of the polar vortex is crucial for maintaining normal winter weather patterns. When the vortex is stable, it helps to ensure that winter weather remains predictable and consistent, with cold air staying in the Arctic and milder air in the lower latitudes. However, when the polar vortex is disrupted, it can lead to significant weather changes. Cold Arctic air can spill southward into lower latitudes, causing extreme cold events in regions that are not typically this cold. This can lead to severe winter storms and unusual weather patterns affecting millions of people. Understanding the polar vortex is essential for predicting and preparing for these weather events. It highlights the interconnectedness of our planet's climate system and the importance of monitoring and studying these atmospheric phenomena. Sudden stratospheric warming, as its name suggests, is a rapid increase in temperature in the stratosphere, the layer of the atmosphere above where we live. This phenomenon can occur over just a few days, causing temperatures to rise by tens of degrees Celsius. It's a dramatic shift that can have significant consequences for our weather systems. This warming event can weaken or even reverse the polar vortex's circulation. The polar vortex is a large area of low pressure and cold air surrounding the Earth's poles, and it plays a crucial role in maintaining the stability of our weather patterns. Imagine a spinning top that suddenly wobbles and loses its balance. That's akin to what happens to the polar vortex during sudden stratospheric warming. When the polar vortex becomes unstable, it can lead to a cascade of changes in the atmosphere. This disruption can have profound impacts on weather patterns far beyond the Arctic. For instance, it can lead to severe winter weather in regions that are typically milder, or it can cause unusual weather events in places that are not accustomed to such extremes. The exact causes of sudden stratospheric warming are complex and not fully understood. Scientists are continually studying these events to better predict and understand their impacts. They use advanced models and simulations to analyze the data and identify patterns. However, they are thought to be linked to interactions between the stratosphere and the troposphere, the lowest layer of the atmosphere. These interactions are crucial in the transfer of energy and momentum between different layers of the atmosphere. These interactions can involve the upward propagation of atmospheric waves, which can transfer energy from the troposphere to the stratosphere. These waves are generated by various weather systems and can travel upwards, affecting the temperature and wind patterns in the stratosphere. This energy transfer can disrupt the temperature gradient that maintains the polar vortex. When the temperature gradient is altered, it can weaken the polar vortex, leading to its collapse or reversal. This, in turn, can have a domino effect on weather patterns across the globe, highlighting the interconnected nature of our atmosphere. When the polar vortex weakens or splits, it sets off a chain reaction in the atmosphere. The jet stream, which normally acts as a barrier confining cold air to the Arctic, can become wavy and elongated, allowing cold air to travel much further south than usual. This phenomenon allows frigid Arctic air to escape southward, bringing unusually cold temperatures to lower latitudes, affecting millions of people. It's like opening the freezer door and letting the cold air spill out into your home, except on a much larger scale. These outbreaks of Arctic air can be accompanied by strong winds, creating blizzard-like conditions that can disrupt daily life and pose serious hazards. The southward movement of Arctic air is not a uniform process. It can vary greatly in intensity and duration. The specific regions that experience the most significant cold outbreaks can vary depending on the exact configuration of the polar vortex and the jet stream at any given time. However, in general, regions located in the eastern United States, Canada, and parts of Europe are more susceptible to these cold air intrusions. These areas often see dramatic temperature drops and severe winter weather as a result. Residents in these regions must prepare for the harsh conditions by bundling up in heavy winter clothing, dealing with snow-covered cars, and navigating icy roads. Emergency services are often on high alert during these times, responding to incidents caused by the severe weather. People shovel snow from driveways and sidewalks, while salt trucks work tirelessly to keep roads safe. Despite the challenges, many people also find ways to enjoy the winter weather, engaging in activities like skiing, snowboarding, and building snowmen. The cold air surges can transform landscapes into winter wonderlands, creating serene and picturesque scenes that are both beautiful and treacherous. The southward surge of Arctic air can lead to the development of a strong high-pressure system over northeastern Canada and Greenland. This high-pressure system acts like a blocking pattern, preventing warmer air from reaching the eastern United States and Canada. Imagine a large boulder blocking a river, causing the water to back up and spread out. That's similar to what the high-pressure system does to the flow of air. High-pressure systems are typically associated with fair and stable weather. However, in this case, the high-pressure system is bringing bitterly cold air from the Arctic. This means that while the weather may be clear and sunny, the temperatures will be much colder than average for this time of year. Section 5, a March deep freeze, impacts on the eastern United States and Canada. As the polar vortex weakens and the high-pressure system settles in, the eastern United States and Canada can expect a dramatic shift in weather. Temperatures may plummet 10 to 20 degrees below normal for March, bringing a taste of midwinter to the cusp of spring. This sudden cold snap can catch people off guard, as they may not be prepared for such extreme temperatures. The combination of cold temperatures and potential precipitation could lead to significant snowfall in some areas. Even regions that typically don't receive much snow in March could see accumulations. This unexpected snow can disrupt travel plans, close schools, and make it difficult to get around. Section 6. Nature's Fury, a threat to agriculture, transportation, and energy. The extreme cold brought on by the polar vortex collapse can have significant impacts on various sectors of society. Agriculture is particularly vulnerable as crops and livestock may not be able to withstand the freezing temperatures. This can lead to crop losses and reduced agricultural yields. Transportation systems can also be severely affected by the cold weather. Roads and railways may become impassable due to snow and ice, while air travel can be disrupted by delays and cancellations. The extreme cold can also put a strain on energy grids, as demand for heating increases significantly. Section 7. Preparing for the Big Chill, a call for action. As the threat of a polar vortex collapse looms, it's crucial for individuals and communities to be prepared for the potential impacts. This includes ensuring that homes are properly insulated, stocking up on essential supplies, and having a plan in place in case of power outages. It's also important to stay informed about weather forecasts and warnings. Pay attention to local news and weather reports and follow the guidance of authorities. By taking these precautions, we can minimize the risks associated with this extreme weather event. Section 8. Conclusion: Respecting the power of nature. The polar vortex is a powerful reminder of the interconnectedness of our planet's systems and the potential for extreme weather events. As we continue to learn more about these phenomena, it's essential that we approach them with respect and a commitment to preparedness. By understanding the risks and taking appropriate precautions, we can navigate these challenges and build more resilient communities.